So it's 2.4 application, and you're going, well, we just did some application last section. We did. But the application of Trig in the most practical sense is navigation and surveying. So maps and how to get somewhere with a map, right? So there's some things we need to do. We have two men stand equals, the two equal sides of an isosceles triangle are each 24 centimeters. So I need to draw a what? Isosceles triangle. So 24 and 24. And it didn't say a right isosceles triangle, so our assumption is that it is not. So don't make it look like one. If each of the two angles is 52 degrees, so that means across from it, so 52, the base angles, and 52. Find the length of the base and the altitude. So the altitude is what drops and makes a right angle. So we'll call it H just because it's the height. And we'll call this B. So what do I have here that can help me do that? H should be fairly simple.
Yeah, you have. It's sine.
It's sine because opposite and hypotenuse.
Yeah.
So sine of 52 equals H over 24. So H is going to be 24 sine of 52. And I always just wait to put it in my calculator when I'm done. Okay, so I got H. Now B is a little bit different. Am I going to use the whole triangle to find it? Can I use the whole isosceles triangle to find the base? Sam, rattle those rocks more. She said no. Why not, Sam?
It's not right.
Thanks, Sam.
No.
Because it's not right. So we're going to find one of these. So what do you want to call it? X? And multiply it by what? 2. Okay, so now we want the adjacent, we have the hypotenuse, we're going to use what?
Cosine.
Cosine. So cosine of 52 equals X over 24. So X equals 24 cosine of 52. But the base equals what? 2 times 24 cosine. And why 2? Because there's 2 of them. So put those in your calculator and tell me what you get about. And they give you whole numbers. So it says round to 2 significant digits because 2 and 4 are both significant. Just they gave you whole numbers. Give me whole numbers. Okay, 19, and there were units, but I didn't tell you, centimeters. 19 for H. And the base.
30.
Now, this was made easier because I gave myself a picture that I could touch, I could manipulate, and work on. Little pictures aren't going to do you any good. If you can't read what you're writing on your picture's too small. Again, I got scratch paper over there. Use it. You don't have to be using your lined paper. On these, I tend to go to just blank paper because then I'm not worried about how much space I'm using. Okay, a definition that we need to know is angle of elevation. Always starts with the horizontal or the horizon and goes up. Horizon and goes up. Show yourself that with your arrow. That is angle of elevation. Angle of depression. Elevation means to go what? Up. What does depression mean? Down. Starts from the horizon and goes down. You will also see or hear angle of descent. What does descent mean? Down. Depression, descent. You will see ascent sometimes, but not very. But ascent would be elevate up, right? You'll see angle of incline. That means what? Up. Angle of decline means down. But the key point is they all start with the what? The horizon or the horizontal. The ground, if it's going up, basically, correct? And the horizon if it's going down. Okay. I've got, if a 75-foot flagpole casts a shadow of 43 feet long. So we probably should draw a flagpole, yes? Flagpoles, unless it tells you otherwise, are what? They're vertical, correct? Okay, so here's flagpole, and it casts a shadow of 43. Well, here's my shadow. And I always like to add a flag. This is how I know people don't know what's going on, is their pictures get really amazing. Their pictures get lots of detail when they have no clue what's going on. Okay. To the nearest 10 minutes, so I have to do degrees minutes, what is the angle of elevation of the sun from the tip of the shadow? Well, if the shadow is here, where's the sun? In front or behind? If the shadow is here, where's the sun?
Oh, there.
Over here, right? Here's the sun. Now, does your picture need that much detail? No. But it says the angle of elevation. So which angle is that? The bottom one. It's this one right here. Okay, so it told me the flagpole is 75.0 feet. And it told me the shadow is 43.0 feet. So how am I going to find that angle?
Didn't I say the angle was 42?
No, you are finding it. It says to the nearest 10 minutes, what is, it said that shadow is 43. How am I going to find that angle?
Tangent.
Okay, but inverse tangent?
Yeah.
Okay, because inverse finds an angle, right? And I have opposite and adjacent, so inverse tangent of 75 over 43. So that's approximately 60.17 degrees, but they said to the nearest 10 minutes, yes? So I got 60 degrees. How do I get 0.17 to minutes?
It's divided, isn't it? Times?
Times, because you're taking a decimal and going bigger.
Oh, right.
So 0.17 times 60. So 0.17 times 60 gets you 10.2. So that would be 10 minutes. So theta is approximately 60 degrees, 10 minutes. Okay, this is the rule of thumb. If they give, we cannot work with this. 60 degrees, 10 minutes, we would have to make it into 60.17 to work with it. But my answer, if I have to give an angle back, would have to be back in minutes. Does that make sense? You have to put it back in where, but we cannot work with minutes. You have to put it into decimals. Well, with the new calculator you can, because you can put degrees and minutes in.
So like the phone one?
Yeah, but I'm not going to let you do that. So.
Need to do that.
It's easier just to change it.
I would rather change it, to be honest.
Okay. A man climbs 213 meters up the side of a pyramid. Probably need to draw a what? Pyramid. So that means this is 213 feet, right? Oh, meters, not feet. And I'm not in my erasable pen. I'll just put it on this side. And finds that the angle of depression to his starting point is 52.6. So he's up here, right there. So his angle of depression, so it goes from the horizon which way? Down is 52.6 degrees. How high off the ground is he? Well, the height off the ground he is what?
The middle line.
The middle,
What's it called?
the altitude of the pyramid or the height, doesn't matter. Okay, so that's what we have, yes? So we can do a couple of things. We can remember our geometry. And if this, because this, the horizon is parallel with the ground. Correct? So that means that the side of the pyramid is a transversal. Yes? Which would mean 52.6 is also where? Right there. Or this height, right here, also could be where?
On the other side?
Couldn't it be right here? Outside the triangle? So are these two triangles I just made congruent? Yes. I don't care which method you use. Some people like to put the 52.6 in the pyramid. I just draw the height on the outside. I think it's easier. Does it matter? So because if I put 52.6 here, I would have opposite and hypotenuse, which would be sine, correct? If I left it on the outside, I still want the opposite and have the hypotenuse, don't I? So either way, it's still going to be sine, isn't it? So sine of 52.6 equals opposite height over 213. So the height equals 213 sine of 52.6 degrees. So are there multiple ways to do these problems? I get the height to be approximately 169 feet. It's like 169.2. Oh, not feet, meters. Okay, so which one do you guys think you would do? Put everything inside it or just drop it from the outside?
I like the outside.
Everything inside.
You would do everything inside. Okay, this is my only problem with the inside. When people do that, guess where they put the 52.6? They don't put it here, they put it where? There. And is that an angle of depression?
Can't you take that to
No.
You could subtract,
Yeah.
but that would be, like, what if I screw that up? People will take that 52.6 and put it inside here, and that's not an angle of depression because it's not with the horizontal. If you're putting it inside, it has to go alternate interior. Because we have parallel lines, transversal, so alternate interior. I like simpler the better. Okay, we're not going to do the topographical map. You should not be doing the topographical map. No. Oh.
We're not doing that for that?
Well, we can.
No, we don't need to, Nick.
I have it on there.
No, you don't need to.
It's okay.
On the assignment?
Yeah, I do.
What's wrong with you?
You haven't figured this out? What's wrong with me?
Well, I don't know.
We're gonna take 13. Say don't do 13. So don't do 13. Everyone see that? Okay,
Yeah.
and
Do these tomorrow too?
what?
Do this tomorrow too, or?
Well, we did not get to the navigation stuff, and we need to get to the navigation stuff. So your assignment, you should be able to get through 15. You should be able to go 87, 1 through 15 odd. But don't do what? Don't do 13. And I'm okay with that because we didn't get through notes because you guys had questions. I'm totally fine with that.